3 years ago, you bought that SSD, plugged it in, and forgot about it. And that forgetting might be the most expensive mistake currently sitting inside your machine. I'm not talking about a glitch or a slowdown you can live with. I'm talking about the possibility that your drive is approaching the end of its right life right now, silently, without a single warning light, without a single error message. And when it goes, it typically doesn't give you a heads up. It just goes. Everything on it, gone. What makes this so dangerous isn't the failure itself. It's that most people have absolutely no idea it's coming. You check your task manager, your temps look fine, your PC boots fast, and you assume everything is okay. But there's a number buried inside your SSD right now that tells a completely different story. In the next few minutes, I'm going to show you exactly how to find it, what it means, and what to do before it's too late. Here's something the spec sheet never told you. Every single time you write data to an SSD, you're burning through a finite resource. And most drives are much closer to that limit than you think. To understand why, you have to understand how NAND flash memory actually works at a physical level, because this isn't a software problem. This is physics. SSDs store data in cells made of a material called floating gate transistors. Each time data is written, electrons are pushed through an insulating oxide layer to change the charge state of that cell. That layer is incredibly thin. We're talking a few nanometers, and every write cycle degrades it slightly. Over time, the oxide layer breaks down. The cell can no longer hold a reliable charge, and that cell becomes unusable. The drive's internal controller marks those cells as dead and reroutes around them. But there are only so many cells to reroute to. When you run out of healthy cells, you run out of drive. Now, how fast this happens depends on the type of NAND your SSD uses. If you have a budget drive, something in the $40 to $70 range, it's almost certainly using QLC NAND, which stands for quad level cell. Each cell stores 4 bits of data instead of 1. That sounds efficient, but the trade-off is brutal. QLC drives are typically rated for somewhere between 100 and 300 write cycles per cell. TLC drives, triple level cell, which cover most mid-range consumer SSDs, sit around 500 to 1,000 cycles. Higher-end MLC drives can reach 3,000 or more. So if you bought a budget QLC drive 3 years ago, and you do heavy work on it, video editing, large file transfers, virtual machines, you could be in genuinely dangerous territory right now. The metric that actually tracks this wear is called TBW, terabytes written. Your manufacturer assigned your specific drive a TBW rating when they built it. A typical 1 TB budget SSD might be rated for 150 to 200 TBW. A mid-range drive might hit 300 to 600. An enterprise-grade drive can go into the thousands. And here's the critical part. Your SSD has been counting every single terabyte written since the day you turned it on. That number lives inside the drive's smart data, self-monitoring, analysis, and reporting technology. And you can read it in about 60 seconds with free software. We'll do that in a moment. Now, I want to be clear about something that independent storage researchers at organizations like Backblaze have documented through years of real-world drive failure studies. Backblaze publishes quarterly reports on drive reliability across hundreds of thousands of drives in their data centers. This isn't lab data, it's field data, and what they consistently find is that consumer SSDs show a sharp uptick in failure rates after the 3 to 4 year window, particularly in drives that have seen heavy write activity. Tom's Hardware conducted endurance testing on QLC drives and found several popular consumer models hitting their rated TBW limit within 2 to 3 years of heavy use. AnandTech's storage benchmarks have repeatedly flagged that manufacturer TBW ratings are often conservative estimates, but often isn't always. And a drive that hits 95% of its rated TBW is not something you want to treat casually. Think about what that means for you personally. You might have 6 years of photos on that drive. Financial records, project files for a business you've spent years building, a thesis, a novel, work you cannot recreate. All of it sitting on a component that has a physical write limit, and that limit may be closer than you realize. That's not a scare tactic. That's just the reality of the technology. And the reason most people don't know about it is that no one in the retail chain has any financial incentive to tell you. I want you to stop and think about what's actually on that drive right now. Not just files, but the stuff that would genuinely hurt to lose. Because here's what I think happens with storage. We treat it like furniture. We set it up once, we stop thinking about it, and we assume it will just be there. But an SSD is not furniture. It's more like a battery. It has a charge cycle limit, it degrades over time, and it doesn't announce when it's about to quit. When I started digging into this, specifically after a friend lost 3 years of freelance design work to a failed NVMe drive that showed 0 symptoms beforehand, I realized something uncomfortable. Most of us make regular backups of the things we think of as important, but we don't think of the operating system drive as data. We think of it as infrastructure. And so the photos from last year's family trip, the QuickBooks files for a small business, the game saves, the browser profiles, the password, vaults, the locally stored email archives, all of that just lives on the drive, unprotected, assumed to be safe because the drive hasn't thrown an error yet. Here's the thing about SSD failure that makes it different from traditional hard drives. HDDs often give you warning signs, clicking sounds, read errors, slowdowns you can hear and feel. SSDs fail silently and suddenly. One moment the drive is working, the next, the system doesn't see it at all. There's often no gradual decline, no opportunity to copy your files over. Researchers at Carnegie Mellon University studying flash memory reliability found that a significant portion of SSD failures happen without any prior smarty. Error flags, meaning even the built-in monitoring system doesn't always catch it. The drive just stops. And I think what frustrates me most about this is that the information to prevent it is all there. It's inside the drive. You just have to know how to ask for it. The storage industry knows about write endurance. Drive manufacturers know about it. They build the TBEW rating right into the spec sheet. But they put it in the fine print, use technical language most people never decode, and count on the fact that the average buyer is never going to check whether their drive is at 12% or 94% of its rated write capacity. That's not an accident. A customer who understands their drive is near end of life replaces it on their own timeline. A customer who doesn't know loses their data and buys a new drive in a panic. The outcome for the manufacturer is the same, or better, because they didn't have to field the support call. You're not being paranoid for caring about this. You're being rational. So let's actually look at what your drive is telling you, because right now you don't have to guess. All right, here's exactly what you're going to do, and I'll walk you through every step because the numbers you're about to see will either give you peace of mind or save everything you have stored. This takes about 10 minutes total, costs nothing, and requires no technical background. Stay with me here. The first tool you need is Crystal Disk Info. It's free. It's been around since 2008. It's maintained, and it's the most direct way to read your drive's smart data on Windows without needing to interpret raw hex values. Download it from the official CrystalMark website. Just search Crystal Disk Info Official and grab the portable version if you don't want to install anything. When you open it, it immediately scans every drive connected to your system and pulls the smart attributes into a readable table. The color at the top of each drive's panel tells you the overall status. Blue means good, yellow means caution, red means bad. But don't just look at the color. Drill into the specific values, because the color can lag behind what the numbers are actually saying. The three numbers you're looking for specifically are power on hours, which tells you how long the drive has been running since it was new, total host writes, which is the actual TBW consumed expressed in gigabytes or terabytes depending on the drive, and the percentage used or wear indicator value, which some drives, particularly Samsung and Intel, report directly as a remaining life percentage. If your drive shows a wear indicator of 100, that's 0% life remaining. If it shows 97, you've used 3%, you're fine. If it shows 20, you're at 80% consumed, and depending on your usage rate, you may have months, not years, left. Now, not every drive reports the wear indicator in the same format. Some report it as percentage used, some as percentage remaining. If you're not sure which way your drive reads it, look it up by model number. Just search your drive model plus smart wear indicator direction, and you'll find the answer in about 30 seconds. This matters because misreading it in the wrong direction is the difference between thinking you're fine and actually being fine. Once you have your total host writes number, compare it to your drive's rated TBW, which you can find on the manufacturer's product page by searching your exact model number. If your drive is rated for 300 TBW and you've written 240 TB, you're at 80% consumed. That's your alert threshold. At that point, I'd argue you should treat the drive as if it could fail tomorrow. Back everything up, order a replacement, and start planning the migration. You don't have to pull the drive immediately, but you should stop treating it as reliable long-term storage. The second tool I recommend running alongside Crystal Disk Info is Crystal Disk Mark. Same developer, different purpose. While Crystal Disk Info reads smart data, Crystal Disk Mark runs actual read and write speed tests on the drive. A healthy SSD should hit read speeds close to its rated spec. If your drive is rated for 3,500 pound rate sequential read, and you're getting 2,100 when you memo embarrasses, that's a sign of internal degradation. The controller is working harder to compensate for bad cells. Not a death sentence, but another data point worth noting alongside your smart data. For Mac users, the built-in tool is Disk Utility. Go to Disk Utility, select your drive, and click First Aid. It runs a basic integrity check, but for deeper smart data on Mac, the best free option is a utility called Drive DX, which has a trial version that gives you a full health snapshot. It presents TBW consumed, power on hours, and a risk score in plain language. On Linux, the command you want is sudo smartctl, a dev-sda. Replace SDA with your actual drive identifier, which you can find by running lsblk first. The output will include raw read error rate, reallocated sector count, and wear leveling count, all of which tell a story about your drive's remaining health. Now, once you have your numbers, here's how to act on them. If your wear indicator shows less than 50% consumed, and your total, host writes are well within the rated TBW, you're in good shape. The action here is simple. Set a calendar, reminder to run this check again in 6 months, make it a habit. If your wear is between 50% and 80% consumed, this is your yellow zone. You should back up everything important right now, not eventually, right now, and seriously start evaluating what you'll replace it with. If you're above 80% consumed, or your drive is throwing caution flags in the smart data, treat it as already failed. Get your data off it today. Don't run any large write operations on it. Don't defrag it. Don't move large files around on it. Just back up and replace. For backup, the simplest approach is a combination of local and cloud. An external hard drive for local backup. 2 TB external drives cost around $50 to $60 and give you instant offline access to your data and a cloud service for offsite redundancy. Backblaze Personal Backup costs $99 a year, has no file size limits, and runs continuously in the background. If you're already on a Microsoft 365 subscription, you have OneDrive with up to 1 TB of cloud storage you may not be using. The point isn't which service, the point is redundancy. 1 copy of your data is not a backup. It's just the original. A quick note for anyone in an enterprise or professional IT environment. Your organization likely has asset management and drive monitoring protocols already in place, and drive replacement decisions should go through your IT department. The steps I've described here are for personal systems and home setups. If you're managing a server or a RAID array, the calculus is different and the stakes are higher. Consult with a storage professional for that context. Now that you know what your drive is actually telling you, I want to be straight with you about what this means, because there's a version of this where you do nothing and pay for it, and a version where you spend 20 minutes today and protect years of work. And honestly, the decision is simpler than it seems once you have the data in front of you. Here's the bigger picture. We live in an era where our most important records, financial, personal, creative, professional, exist almost entirely in digital form. And we've developed this strange cultural assumption that digital equals permanent, that if it's on a drive, it's safe. But the reality is that all storage is temporary. Hard drives fail, SSDs wear out, cloud services get discontinued, RAID arrays experience correlated failures. The only thing that actually protects data is redundancy. Multiple copies in multiple locations on multiple types of media. That's not paranoia. That's just how professional archivists and data centers have operated for decades. The difference is they built systems around that reality. Most of us haven't. What I want you to take away from this isn't anxiety. I want you to take away agency. You now know where to look, what the numbers mean, and what to do about them. That's a different position than you were in 20 minutes ago. And that knowledge compounds. Because once you start checking your drive health regularly, once you build a backup routine, once you stop treating your storage as infrastructure you can ignore, you make yourself genuinely resilient against a category of data loss that hits millions of people every year who never saw it coming. You're not the person who loses everything because a 3-year-old drive hit its write limit on a Tuesday afternoon. You're the person who checked, who knew, and who had a copy ready when it mattered. That's the outcome here. And it started with one 60-second scan in a free tool. If this gave you something useful, whether it's peace of mind because your drive is healthy or a wake-up call, that sent you straight to your backup drive. Hit subscribe. I cover this kind of deep dive hardware and data protection content regularly, and I go into the details that most tech channels skip over because they assume you'll figure it out. You shouldn't have to figure it out. Drop a comment below and tell me what your wear indicator said. I read every single one. And honestly, I'm curious how close some of you are cutting it. See you in the next one.